this is the guide you were looking for, the ultimate AI guide for everyone. In this guide, I won't only show you the theoretical areas of AI, but I will allow you to immerse in this world of AI with hands-on projects and precise explanations. This guide will go step by step all the way from the machine learning basics to the natural language processing projects. So don't miss future episode, hit the subscribe button, share with all your friends, and now take a seat and we are ready to start. The first episode will be about supervised learning. Machine learning is a part of artificial intelligence that focuses on creating algorithms that allow computer to learn and make decisions using data, instead of following explicit instructions from programmers. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Today we will take a closer look at the supervised learning algorithms, focusing specifically on regression models. In supervised learning, the model is trained on labeled data. That means the model sees all the corresponding outputs with inputs in the training set, and then it makes output predictions from unseen inputs. Let's imagine this on a new example. We will teach the model with car price prediction dataset in this video, where the input data will be the brand, mileage, year of manufacturing, and also some other, but we will get to that when we will be coding. Now, only these three and the output value, the price of the car. The model will learn on this data, and then when I go buy a car in the future, I know the car is Mercedes with 100,000 kilometers and the year of manufacture is 2015. I can easily spot that the salesman is trying to cheat me out of money, because he is trying to sell me this car for 150,000 euros, but when I put this data into my model, the estimated price by the model is only 60,000 euros. That's the reason why you should watch this video till end and subscribe, because this will help you not only with your coding skills, but also in your real life, you'll see. This type of supervised learning is called regression, because we predict exact price of the car. There is also the second type of supervised learning, the classification, which does not predict the exact number, like the price, but the class where the certain thing belong, depending on the input features. Before we start coding, let me quickly show you the demo, how the project will look like. We will code everything in Jupyter Notebook by using Python. Don't worry, I will guide you how to set up this project also. Firstly, in this file there will be also explanation of how everything works, and you can find everything in my GitHub repository. All the links will be in the descriptions. So let me show you the project again. We'll import the necessary libraries. We will have our own dataset with car prices. We'll load this data, pre-process the data. Then we will also again more pre-processing the data. Then we will train our model, make some prediction with our model, and compare the real prices and the predicted prices, and also make an evaluation of our model. That will be everything for our episode, but I will go step by step, and I won't only write the code, but I will explain you why and doing every step. So you can use this in not only this one project, but also the similar projects. To start our code, you need to create a folder somewhere. We'll create a new folder here. Name this folder regression video, for example. I will open this, copy the whole path by clicking here. I don't know if I copied the whole path, like, yeah. Ctrl+C, open your favorite commander. write cd for change directory, paste the path, press enter. Now we'll code this project in a Jupyter notebook. You can simply install Jupyter notebook by writing pip install notebook, but I have already installed this pip package, Python package. You see, but I can upgrade my pip, but I don't want to do it. If you install your Jupyter notebook and you are in that folder, write the Jupyter notebook and it will open a new instance of Jupyter notebook file where we will code. Oh, the one open new. Okay, you have to press new file, new notebook. Okay, like this. Okay, kernel, Python, select. Title of the project will be regression model. Enter. I will check if the Jupyter notebook file is created in our folder. And the second thing you need to do is open my GitHub repository. The link is in the description. Click on this CSV file. This is the file with our data. A lot of data, like thousands of rows. Download this file, the raw file. Open new file instance. Go to downloads. Find your folder and move the CSV file to your folder. Now the setup is ready and we can start with the code. From this moment, everything what we will do will be in this Jupyter notebook file. In this Jupyter notebook file, you can select if you wanna write the text, the markdown or the code. I will make a header for every code so you know what you are doing. I will here to write a title of some subsection. I will write here just importing libraries. Is press shift enter. This will run the code, or you can press this little arrow. Here, this the code cell. I will import the first 3 libraries. We will use more libraries later on, but these are the basic one you will use very frequently. So import numpy as np for numerical calculations. Import pandas spd for data frames, like how to store your data into the tables. The third one is import matplotlib.pyplot splt for visualization for the graphs and stuff like that. Press enter. One moment, if you haven't installed, I think in the Jupyter notebook these libraries are pre-installed, but if you are not sure, go to your favorite terminal, open new instance of the terminal because you are running the Jupyter notebook. So write it here like commander, install pip, install numpy, and with the other libraries do the same. But I hope that you use these libraries before. I truly hope. After importing our libraries, I will check if the dataset is correctly located and we will load this dataset to our file. So let me write another title. Loading the dataset. Shift enter or this arrow to run the cell. Here I will write the code. You see, you are getting to it. I will write the code. df will be the object where we will store our dataset. It's data frame. It's the special object from pandas. So pd read csv is function to read the csv files, and our file is called car predictions.csv, and I will print out this data frame. Shift enter. Something is wrong. I will check car prices. No, no car predictions. This is the name of the file, car prices, and this will be our dataset. Our dataset will have a lot of columns and a lot of 3000 rows. There will be a card brand. In our case, everything will be Opel. The model of the Opel, the generation of that model, the year of manufacture, when the car was born, the mileage, how many kilometers has this car, a wall engine, I don't know what's that, but it's okay. Fuel, what fuel is using that car, the city of the previous owner, the part of the country of Poland of the previous owner, and the price in Polish money. You see there are some sketchy columns that we don't want to use. They are not appropriate for our model, so we need to do something about it. That will be our next task, to do something about these weird columns, to alter them, to remove some of them. I hope you are exciting and we can move on. But before that, I will print also some this pandas library allows you to do use some built-in function, like shape of the data frame is like this, 3104 rows and 10 columns. It can allow you to print out the columns. These are the names of the columns, and if you wanna look for another useful functions from these pandas, just write to the Google pandas and search it in the official documentation, or use ChatGPT. We are getting to the data preprocessing. But why do we use data preprocessing? Data preprocessing is important to make our AI model faster and more reliable. There could be a situation where in our car prediction training set is the favorite ice cream shop of the previous owner. This is totally useless for us. We can easily delete this whole column and continue with our training. There are many more examples of data preprocessing, but this is the easiest one to explain, and I will show you the other with the hands-on project. Continue with the code. Our next section of data preprocessing will be splitting the dataset. We have all the inputs here and also the output together. We need to split this into the two parts, into the input features and into the output feature. So here I will also make markdown, splitting the dataset. Now I will use this arrow. In the code section I will use another pandas function. The X, the capital X will be the input features. This is the convention to use in the data science to name the input features with the capital X and the output features with the lowercase y. Data frame that ilog, integer location, square brackets. This is the similar to list slicing in the Python. The first is for the rows. This means all the rows, and all the columns expect the last one. Why data frame ilog? I need also all the rows, but only the last column. Now I will just move it a little bit, print out our input features and also the output features and the cell. In our input dataset is now 9 columns, and the last column is in our output dataset. When this data frame in pandas has one column, it's called the series, and you use almost the same functions for this dataset, but there are some exceptions. We will see one. The prices are in a Polish money, the Polish zloty. We don't want to use it, so I will just write here. We need to check how many zloty is for 1 USD. So Poland to USD is 0.26. For 1 Polish money you get 0.26 of a dollar. That means you need to multiply every row by 26. And this Python, you can simply do it like this. And then print the y again. You see the prices are different, but the name of the column is still the same. To change name of data frame is different from the changing the name of the series. In the series, you can simply write the name of the series. That name is equal to the, what's the name? The name is price colonna. So now it is price USD. Press enter. Yeah, this is the first series before the name change, and this is our the final result of this part of data preprocessing. In our dataset there is many columns that we do not need. For example, this province of the previous owner. That's not important for our model. Train on this data to go through all the 3000 rows, and it can give a different result when we keep this column. We don't need this column. We will filter our columns for the columns what we need and for the columns what we don't need. What columns we need? Check this. I will open the whole CSV file in, for example, in notebook. And you see the car brand is Opel everywhere because it's the favorite car of the Polish people. I don't know. The model of Opel is different in most of the rows, so we will keep the model because the model will define the final output price. What about the model generation? As we just scroll down the model, and the model generation is the same pair every time. Do we need it? The generation name, we will see. I will tell you later. The year of manufacture we need, the mileage we need, the wall engine we need, the fuel we probably need, but to make it simpler I will leave it because we will do some we will change this string column to numbers, and I don't want to do it twice. To make it simpler for the first time, we absolutely do not need the city and province of the previous owner, and the price is already in our output dataset. So that's okay. For this generation name, we can see that this is the same pair every time. The combo is with Gen D 2011. The Vectra is with Gen C 2002 until 2008. If there is the same model every time with the same generation name, we simply can leave one of the rows, one of the columns. I will check it in the next section of our code. Deleting unnecessary columns, run the code, and there aren't pre-built functions for everything, so we need to check it manually, and for this you need to know Python. I will do it simply just by creating a dictionary with the key value pair of key. It will be the model, and the values will be the values of the generation names that are assigned to the model in our dataset. If every model will have one generation name, we can remove the column. If no, we have to keep it. I will create a dictionary, the empty dictionary, just writing the models is equal to the curly braces, and now I will iter through all the rows. You can iter the for loop in Python like this for something in blah 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 in data frame, but to iter through the pandas data frame you need to use the pre-built function iter rows, and in these iter rows you need to not only get the value but also the index and also the row in the data frame. In this row I will find the column with the model like this, and this will be our model. The generation name will do the same. Generation name is equal to the row. Find the column with the name of the generation underscore name. Generation underscore name. And if model is not if the model not in the dictionary yet, I will add the model as the key to a new value in this dictionary, and the values, the key value pair of the dictionary, the values will be the empty set, because the set is like the array but only with the unique values. There are no duplicate, so it is very suitable for us. And the models dictionary model, I will add the value of the values. I will add here the generation name. If the generation name is there, nothing will happen. The Python will simply check if there is the generation name. If not, we will add. If is there, so nothing will happen. Okay, we have this done, and now we need to iterate through this dictionary if every model has only one value. To iterate, you use same for loop, not data frame, but the dictionary. To iterate through the dictionary, use this function, the items, and also for the items, you are iterating through the key value pair. So you can write the key value, but you don't wanna do it. You wanna write the name of the model and the generation name. It's more comprehensive to read. Now, if the length of the generation name set is higher than 1, we'll print out the model through the f string like this, and curly braces, enter the model, and it will write the string name of the model variable as more than 1 generation. You cannot delete the column, and here I will define a boolean value. Okay will be equal to true, and if the model has more than one value, the okay will be false. And if okay, now it's true. If everything is okay, you can delete the generation name. Run the code. To check if our code is working, we can also print out the len of the generation name set. Okay, there is only if the len is higher than 1, so I will do it here. See, every model has only one generation. I will leave it there, and everything is okay. So we can alter our dataset by the integer location of the pandas pre-built function. I need all the columns still, and here you can specify also the list of the columns you need. You don't always need to do this slicing. So we need what columns we need. We need the car brand, we don't need. The model we need. So this is the 0th column. So we need 1, 3, 4, 5. 1, 3, 4, 5. And print the dataset. Okay, the mistake is that we haven't stored this alteration. Now in our dataset are only the important informations, But there is the column with the string values. How do you wanna teach a model with the string values? It's impossible to encode our first column into the numbers. I will import models and the classes from a new library, the sklearn. It is the most useful library for machine learning and data analysis. So from sklearn compose, we'll import the column transformer. It is the class to transform our columns. I will show you. You can search in the documentation. The column transformer applies transformers to columns of an array or pandas data frame. We have pandas data frame and applies transformers. We need to define these transformers here. And for this, there is also one predefined transformer in this sklearn.preprocessing import one hot encoder. And what this one hot encoder does, it will create a vector with as many numbers, as many different strings are in these model columns. For example, you see 2 different values right now, but there are more. It will create the vectors with zeros, like one vector with 0, 0, 2 new columns. And in this column for combo, the first value will be 1 and the second will be 0. For the vector, it will be vice versa. First value will be 0 and the last value will be 1. I think you got it. Every time the value is something, it will put the 1 into the vector and otherwise 0 for other values. I will show you so you can get it more easily. So object ct, the column transformer, use this class transformer. I need to put here the parameter transformers. I showed you. The syntax is like this. The name of the transformer, I will call it encoder. Here, what transformer you wanna use? I wanna use that one hot encoder, and on which column you wanna apply this transformation on the first one. Close these brackets. Now, what do you wanna do with other columns? There is the parameter reminder. You wanna just pass through, just leave it as it is. Our data frame, I will do the ct.fit or learn this transformer on our data and also transform our data. We will need the numpy array. It will be another way how to store our value. Array, cannot write like this. And I will print out the dataset right now so you can see how does it look like. It has the default value of the numpy array is float, so I need to change it. The x is the same as type integer. And you see it created a lot of columns, new columns with value 1, 0, 0 or 0, 1, 0. It depends on which string is in this model column. I can show you more. We'll print out the first row of our dataset. I cannot run this code again. No, I fucked up, I think. If you run this code again, it will transform this first column again with this one hot encoder. This is the mistake you cannot do. You just run this cell once and put this print out into another cell. So what I need to do is to run on all the cells. And now I think it's correct. There are how many models are there? Let me check quickly. Notebook. There is, okay, I will manually check. There is the Combo, Vectra, Agila, Estra, Insignia, Vectra. Okay. I think there are 5 of them, okay? You can check it also here. Where can I check it? Here, there are 5 models, because there is the 5 different values for key in this dictionary. So this is okay, and you see that for the first value, the model is encoded as 00100. If it's Astra model of Opel, it could be like 01000. And this allows us to put this more efficiently to our model, and it can learn from the numbers. The regression can happen from the numbers, not from the string. We have all the training data in one dataset. But to create the test data, we do not have to create new data. Just simply divide our full dataset into the training data and the test data. It's better to test the performance of our model like this, because it won't overfeed on our training data, and we will be sure that it is working for new unseen data. And we did this data preprocessing before the splitting to training and test data set, because we need to have the same, for example, this vector for the combo in test and training dataset. We need to have the same columns and stuff like that, because if we put the same inputs with different meanings, it won't make sense. Markdown, splitting data set into training and test dataset code. For this, there is sklearn model selection. From I will import the train split. The syntax is, you will write here 4 dataset. The first one is the training dataset input. The second one is the test. The third one is the outputs of the Y-train and the inputs of the test. Here I will put is equal to the train test split. The parameters are the X, the Y, the training and test dataset, the full one. Now the test size, the size of the test dataset will be like, for example, 0.25 is a good value for this. And the last parameter, random state, it is for produce the same result every time you run this exact code, like this. Now I can print out, for example, the X train and X test. I will print out something between these datasets, something between. Run the code, and this is the train dataset, this is the test dataset. Same I can do with the output values. You see, and it is divided into 75% into training dataset and 25% into testing dataset. Clean this. Run this code again. We are getting to the learning our model. How does supervised learning work? How does this learning process work? We can imagine it on a simple example of our data. We will create a graph. On x-axis, write the mileage of cars, and on the y-axis, we will write prices of these cars. The training of the model is not anything else than iterating the same mathematical operation over and over, 100 times, 1000 times, or even millions of times. But don't worry, you don't have to be expert in this from the beginning. You will understand it step by step. All you need to know is that the model will, for example, draw a line with the default values, and then slowly with each iteration will trying to move this line, it will fit the data most accurately. This is how it can and it will find the correlation between our training dataset even in the millions of rows, which is impossible for humans to see in that short period of time. If you wanted to dive deeper in this topic, I will leave a video with a mathematical explanation in the description. Just follow this guide till end, and the next time you wanna learn something new, try to watch this video. You cannot build a temple in one day, it needs time. Back to the code. Markdown. Training the multiple linear regression. For this there is a pre-built function from sklearn linear models, import linear regression. There will be the object, the regressor, which will be the instance of the linear regression, and this object is basically our model, and I will train it with this feed method, which means learn in the machine learning, and I will put here the training dataset and the input and output features. Press enter. Something is wrong. I see where is the mistake. The code is correctly written, but I need the parentheses here to call this function, not the function, the class. And now we have successfully trained the model. In the next step we will make predictions, and then we will try to find out the accuracy of the model, and that will be everything. Now it's time to do predictions. We can simply use this regressor we call direct, the instance of this class linear regression, to do the predictions, because we learn this model already in this code snippet. The y pred will be the numpy array with the predictions. I will use the rect predict from the y test. Press enter. Here I can print out the y pred. You see it is a numpy array, so the default value, as I said, it's float. These are the prediction for the prices. This is the first row, second row, third row, and so on. Let me just adjust the numbers a little bit to make the precision more clear with the only two digits, nor not like 20 digits after the decimal point. You can do it with the numpy set options, set print options, precisions will be equal to 2. Now when I print any numpy array, it will have the precision of 2. Okay, let me just comment this like now. As you can see, there are only 2 numbers after the decimal digit. What I can do, I have also the y test, the real values. They are here, and I can like concatenate this numpy array and also this data frame series next to each other, so you can see what is the difference between the predicted value and the real value. To create firstly from the y test, I need to create a numpy array, y test, and now I can print out the concatenation of these 2 numpy arrays. For this concatenation I will use the function numpy from the numpy concatenate. Here you need to put 2 values, the 2 datasets, and from which side you wanna concatenate the numpy arrays, like this or just like the rows. But first I need to put 2 numpy arrays, like y pred will be our predicted value. I need to reshape this numpy array. You see it is not suitable for concatenation. I will reshape it into the 1 column. So the reshape will take, this is like how many rows it will have. You will have that many rows S are the values, the number of values in that data frame or the NumPy array, and 1 column. Close this. The second data NumPy array will be reshaped the same way. Why test 1 column, and I will, when I close this, I'm missing one thing. I have a mistake here with the parentheses. There is no need for this parentheses. This was like first parameter, and the second one is number 1. So I need to concatenate it as 2 columns and also close the print parentheses, and now it should be working. I will just delete this first print out, and you see we have the predicted values and the real values. For example, first car cost 12,000 euros and our predict is 10,000. The third one is very accurate. It's almost 3,000 and no, it's almost 4,000, and our predicted value is so close. And also this one is very close. For evaluation of regression models, you can use this mathematical concept of R square. This is the equation. It is simply in the numerator summing all the real values minus the predicted values, the power of 2, and in the denominator is summing the real values minus the mean of the actual values to the power of 2. And the result, if it's close to 1, the predictions are perfect, spot on. If it's close to 0, the model is working not better than the mean values of the actual values, so it is basically not good model. And if it's minus value, that you are basically fucked up. Your model is totally wrong. I need to do the evaluation once again because I did it with the full screen. I need to write the evaluation like this, write the code. We have the sklearn function. We can import from the sklearn.metrics, import R2 core, and you can simply apply this function to our predicted values by pred and our real testing values. Run the code. The result is 0.84. That means that our predictions are really close to the 1, which I said is very good. Our model is very good. It's predicting the values almost correctly, and that is amazing from like 4 columns only, and this fast learning. But there are some outliers, not gonna lie, it's not perfect, but I hope that you will use this code and you can simply see the process you will do with every future project. You will import the dependencies, set up the project, import the dataset, do a lot of data preprocessing, then learn your machine learning model, AI model or neural network, whatever, train it, like that I meant, predict some new values, and it will be up to you to decide what does these values mean. It is not the work of the computer. You have to know what you are doing and what are this information about. The last, we imported the evaluation, and there are more different evaluations. So for example, this one is for the R2 square, and you already know what is it. And in the next episode we will level up the concept. In the next episode there will be a more difficult level on the different topic, and if you follow this video step by step, video by video, you will learn a lot of topics, a lot of new stuff. In the end you will connect together and create something amazing, and you will learn everything. That's all for this episode. I hope you like it. Hit the subscribe button so this will get to the more people. I can make better content. Like the video, share some amazing messages about anything and have a beautiful rest of your day. Peace.